Hi friends, this is Matthew. I hope you're doing well. Today we're going to discuss about a very important and very useful machine learning algorithm, which is called as the nearest neighbor algorithm. And it's also called as KNN sometimes. And it has a nickname. It is also called as a lazy algorithm, right? We just spoke about three things. Let me tap your memory. The nearest neighbor algorithm, which is NN, and we spoke about the K nearest neighbor algorithm, which is KNN, and also I put a nickname for it. It is a lazy algorithm, right? So what's the difference between nearest neighbor and K nearest neighbor algorithm, right? Let's try and understand that. So there is hardly any difference, right? This nearest neighbor algorithm is also a K nearest algorithm, but what happens here is that the value of K is equal to 1, right? So when the value of K is equal to 1, it becomes the nearest neighbor algorithm. And if the value of K is greater than 1, that becomes K nearest algorithm. So it could be, say, 2 nearest neighbor algorithm or a 3 nearest neighbor algorithm, and so on. It can go on, and finally we generalize it and call it as KNN, which is K nearest algorithm, right? So what is this K? K is nothing but the number of nearest neighbor points to a particular data point which we are interested in, right? If you are interested in only finding out a single neighbor, a single data point who's the nearest neighbor to the query or the test point, that is called as a nearest neighbor. But if you are interested in more than one, say 2 or 3 or 4, that is a KNN. So in that space, we will be interested in finding out minimum 4 nearest data points or 4 nearest neighbors to the test or the query data point what you have given, which you are interested in learning. So that is the only difference between an NN and a KNN, okay? And now we just spoke about it has a nickname that it is a lazy algorithm, right? So let's try and see what is the laziness in this algorithm. So for us to understand what is the laziness in this algorithm, let's try and figure out what are the so-called non-lazy algorithms do when it comes to classification, right? What are the other non-lazy algorithms we know? We know logistic regression, we know decision trees, we know random forest and SVM. The list goes on, right? There are various different beautiful classification algorithms available to us. And what are these guys going to do in a problem, in a machine learning algorithm? So to make it very simple, let me put a Cartesian space of x1 and x2, right? So let's say that, these are the different data points in my x1 and x2 coordinates, right? To make it a little more realistic, I have a different class also here, which is a 0 class, right? Let's assume that this is my data set. So what will a non-lazy algorithm do? It will study the entire data points, which is the training set provided to them. It will create a model, fit a model, and then it creates a classifier somewhat like this, a linear classifier, perhaps if it's a linear relationship. Let's talk about linear relationship, it's easier to understand. So it creates a classification or a classifier, right? There's a classification model, right? So it creates a classifier which can distinguish between the different classes in your y variable, right? So this is the x class and this is a 0 class. So if you are given a query, right? If you put a new data point here and if you want to figure out which class does it belong to, what this so-called non-lazy algorithms will do is that it will fit the test data into it, rerun the model, and figure out what is the probability that this follows to a particular class. So if it is more than 50% probability that if it is a good classification model, it will obviously say that this data point corresponds to the 0 class. And that's what typically the non-lazy algorithms will do, right? So what will a lazy algorithm do in that case? So let's try and understand that. So I'm just going to rub this away and clear this side as well for your ease of understanding, right? So we have got the x1 here and x2 here, right? Let's say that, these are the various different data points provided to your k nearest or a nearest neighbor algorithm, right? These are the examples or the training set of data what you have provided. And for instance, let's assume that you are interested in a query point like this, right? This is your query point. You want to find out the nearest neighbor. So remember, if it is a nearest neighbor algorithm, it is only about one nearest neighbor, right? So, but be it nearest neighbor or k nearest neighbor, this algorithm will have to find out the differences or the distance between each and every data point in the Cartesian space. Okay, so that's going to take some time. It's computationally expensive, right? If you have got millions of data points, this is going to sit and calculate all the million distances, and then it's going to list down it in the memory and sort it and find out which is the closest point by looking at the minimum distance. So visually, if you really look at it, if I'm interested in a single nearest data point, maybe this distance could be the lowest one, and this will be chosen as the nearest neighbor to this data point. So eventually, the properties of these data points will be applicable for this data point as well. So in a classification algorithm, all what you need is that classification. So the classification or the class of this is the class of this. That's the hypothesis, what the nearest neighbor will carry. Say for instance, you are interested in a k nearest neighbor algorithm. You will not be happy with just one neighbor. What you will need to figure out, say for instance, you are interested in k is equal to 3. That's a 3 nearest neighbor algorithm, right? So that means, it is going to calculate the difference between or the distance between all of these things, right? All these data points, and find out the least or the minimum 3 data points and creates a cluster, right? Something like this, right? It will be something like this. So you have got 3 data points and 3 nearest neighbor identified, and the properties of these 3 nearest neighbors will be used to predict the class of this particular query, right? So this is essentially how the nearest neighbor or a k nearest neighbor algorithm will look. So we just spoke about these distances, right? And that's one of the key concepts which you will really need to understand, right? The concepts, I'm going to later summarize it into a table so that you will understand. The first concept you will really need to understand in a k nearest neighbor algorithm is called as distance, calculation of distance, right? So calculation of distance is the fundamental. It's the basic step you need to use in this algorithm to find out which one is near and which one is far. So as I told you that this becomes really computationally expensive when you have millions of data points, right? So to reduce the cost, we introduce another concept called as a tree concept, right? So what is a tree? So I hope that you understood the distance, and let's try and understand what is the concept of trees. Because if you have 1 million data points, obviously a query will have to go through all the 1 million computations, find out 1 million distances, and figure out which is the lowest distance in that. Say for instance, if you are using the concept of tree, right? So if you are using a concept of tree in this, and these are my data points, let's assume that these are my data points, right? Okay. In the Cartesian space, maybe perhaps one here, what a tree will do is typically it keeps on splitting, right? So let's say that this is my first point or the node, and this node will comprise of all the data points. This is the first node with all 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data points. These are all the 10 data points. Now what I'm going to do is that split this 10 data points in this Cartesian space into equal 2 parts, right? How will I do it? I can just split it into 2 equal parts like this, right? How do I do it? I will just need to compute the median of my x1. So let's say that I computed the median like this, and I'm splitting it into 2 different halves, which are nothing but these 2 different halves. So you'll have approximately 5 data points here, maybe 5 data points here and there. There could be a change. So you have already split it into 2 halves. So trees generally give you a classification. This is one type of cluster and this is another. So this splitting rather can continue till the point where you have defined a criteria to stop the split. Okay. So the next split happens onto the left side, maybe here, and it's going to create a split here. So this is another space and this is another space, and here again, it may split like this. So you have got 1, 2, 3, and 4. So again, if you want, that splitting can continue. as long as you want it to continue, right? Let's say that, for ease of understanding in this example, we stop the splitting here. So how a tree is going to help you is that now if you imagine that you have a data point somewhere here, right, which is your test data point. The smartness of this tree is that, it has already defined the space with the nearest points, right? So computationally, it's going to be less expensive because you will not end up calculating the distance between these points and any other data points outside this particular Cartesian space or this particular cluster, right? So you will all need to do is find out the distances between these three data points and find out which is the minimum and assign a class to it, right? So if you are interested in nearest neighbor, it is all about one data point. If you are interested in, say, more than one, which is KNN, say 3NN data point, it's going to take the three distances, and these are the three data points, and see what category they falls into, which class they falls into, and eventually take a vote and determine the class of this one as well, right? So very simple. So distances is the key concept. That's how it will measure the near and the far data points. And then finally, to make it computationally less expensive and more feasible, it comes up with the concept of tree, right? So in order to master this KNN or NN algorithm, you will need to identify and learn very clearly what is the distance concept and what is the tree concept. Once you understand these two concepts, you can apply it in various forms of KNN algorithm. So before I stop this video, let me summarize how it looks like. It's very simple. KNN or NN, what you spoke about, has two major components to it, or rather concepts, I wouldn't call components. One is distance, the other one trees, right? We just spoke about trees. Once you identify and understand these concepts really well, the distance and the tree concepts, yet you're going to apply these concepts on the KNN algorithm to do your supervised analytics, and for NN, nearest neighbor, you have the unsupervised analytics, right? So you can either do a supervised analytics or an unsupervised analytics. In supervised analytics, you have classification and regression, and in unsupervised, you have something called as KNN clustering, right? So this is simply the map, which you really need to remember. Nearest neighbor algorithm or k-nearest neighbor algorithm, two important concepts you need to understand: distance, then trees. KNN further splits into supervised analytics and unsupervised analytics. And in supervised analytics, you have classification and regression. And in unsupervised, you have got something called as clustering. Okay. So in my next video, I'm going to talk about distances in detail. There are various different types of distances we use to calculate the near points and the far points. I'm going to talk a bit in detail about that in the next video, and in the subsequent video I will be discussing about trees, and finally how do you take these two concepts and apply in your KNN algorithm to find out or to do a supervised analytics and an unsupervised analytics in the subsequent videos. Okay, so keep watching my videos, and if you really like it, you can follow and tune into this channel. You will get more videos on KNN and other different concepts of machine learning. So I hope you enjoyed the video. You all have a great day, and keep checking out for the updates in my channel.